What's up you guys, welcome back. Now in this video we are going to be working on composite functions. So as usual, before we get into the exercises, let me cover some basics that you have to know. So there are two main things that you have to know when it comes to composite function. The first is the basic. So what is composite function? Composite function is the combination of several functions. So for example, let's say you've got an input. So this input is x, and this input goes through the function f to give you an output. So this output is known as fx. Okay, now let's say it goes through another function called g. Okay, so this function is another output here, and it gives you, if you write here gx, your answer is wrong. Because why? This is not a gx function, because it goes through two functions to give you this output. So it's not actually gx. How we write it is, some people will say, well, you go through f and then you go through g, right? So you can write fgx. Well, this is also wrong, because when it comes to function, we are actually reading it from right to left. Okay, from right to left. So we are going through f function, so it's fx. After that we're going through g, so the g you write on the left, because you're reading it from right to left. So that means you're going through f function first before you go through g function. Okay, so the output for this entire thing is actually called gfx. Okay, not gx, because it's a composite function. So let me give you an example. How do we solve it? So let's say you have fx, the question gives you fx equals to x plus 2, and also gx equals to 2x. Now let me ask you one thing. If they give you these two functions, and I say ask you to find for gfx, and then I ask you to find fgx, do you think it's going to be the same? Answer is no. These two functions are not, these two composite functions are not the same, because the first one here goes through fx first, only then goes through gx, and the second composite function, it goes through gx first, only then it gives goes through fx. So the answer that you will get is different. Okay, so please bear that in mind. So in this question here, let's say the question asks you for fg5. Okay, so they're telling you, they want you to find g5. After that, you have to substitute into the f function. So the first step is we find g5 first. So g5, so g5 is a normal function, which is what we have done before. So g5 will be 2 times 5. Okay, from here, 2 times 5, because it's 2x, right? So 2 times 5, answer is 10. So now this 10, we know that g5 is equal to 10. So that means this part here becomes 10. So now you're looking for f10. Correct? Because now this g5 here become 10. So you're looking for f10. So you just have to substitute 10 into the fx. So you get 10 plus 2. Answer is 12. So this is how you do it. But this is an easier question because you have the input. They gave you the value 5. Okay, so because they gave you the value 5, the input, so you can do the gx first. Okay, g5. After that, you substitute into the f function. Correct? So you can do step by step. But what if the question doesn't give you that? Sometimes the question will give you something like this. They ask you to find for gfx, for example. So you see here, there is no number. Right? They never tell you it's 5, they never tell you it's any number. They just say it's x. So how are you going to substitute? So in this case, you can't substitute. So what you're going to do is, you're going to take this entire function, fx, you're going to substitute as an input into the g function. Okay, you're going to take the whole thing, the fx function, substitute into the g function as an input. Okay, because you have no value here. So you cannot do like what we did here. We cannot find a value. So you have to do the longer method. So the fx substitute into the g function. So g function is 2x, right? So this x here, you have to substitute with the f function, which is x plus 2. So it becomes 2x plus 2. So your answer is 2x plus 4. Clear? So that's how you solve it. Let me give you another one. Sometimes question can also ask like this. F to power 2 x. So what does this mean? Does this mean square? Now if you write this as square, that means if you write like for example fx, f is x plus 2, right? Then you write like this, x plus 2 square. The answer is wrong. This is not square. What this means is actually double f function. So that means it's going to be like this. So what this means is you're going to take the f function, fx function, substitute back into itself, substitute back into the f function again. So what this means is, you see, f function is x plus 2, right? So x plus 2. But are you going to write x plus 2? No, because why? You have to substitute the fx here into the fx again. So that means this x here will substitute as x plus 2. Okay, so you're substituting the fx into itself. So in the end, you will get x plus 4. Okay, clear? So these are some of the ways they can ask you. So this is the first thing. The second thing that you need to know when it comes to composite function is to know how to determine domain and range. Okay, so this is the second part. Domain and range. Now it is quite similar to the basic function itself, but you know what? To make you all understand this, let me go through an actual example. Okay, let's say you have fx equals to 9 minus x square, and you have gx equals to square root x. Okay, so you got this. So the question asks you to find the domain, right here, domain and range of gfx. Okay, find domain and range of gfx. So the first thing we're going to do, let me just draw it out. Okay, so you see gfx, right? That means it's going to go through fx first, then go through gx, correct? So that means you start with the input x, and then it's going to go through the f function to give you the first output fx. So fx is 9 minus x square. Okay, that's what is given here. Okay, and then it's going to go through g function to give you gfx. Okay, so this is not gx, please, this is not gx. It's going to be gfx. So gfx means you're going to substitute fx into the g. So you get square root x, 9 minus x square. Okay, so this is your gfx. Clear? So now question is how to find domain and range. So domain and range, we can start with the domain first. Remember I told you in the previous, I can't remember, is it a function or inverse function? I think it's a function. I showed you all how to find the domain, right? So we know that when there is square root, the inside here must always be more than or equal to 0, correct? It cannot be a negative number. If it's less than 0, you get a negative value, then it's math error, because square root cannot have negative value. So from here we can find the domain. So we know that 9 minus x square must be more than equal to 0. Okay, so negative x square will be more than negative 9. So x square, so when you remove the negative, the sign must flip. Okay, so x square will be less than equal to, so x will be less than equal to plus minus 3, because you bring the square over, becomes square root. So this is the actual answer for this will be x negative 3 and 3. Okay, so this is the domain. The domain for, the domain for this gfx. Okay, we have already found the domain. So now here's the thing though. The domain of this, so domain means of course it's going to be the input lah. So the domain of this input is going to go through the f function, correct? So that means you're going to substitute all this domain into the f function and it will give you a range. So the range of f function. So here's the thing though, the range of the f function is going to be what? It's going to be the domain of the gx, right? Of the g function, correct? It's going to be the domain of g, and then you get a range, correct? So that's what we're looking for. We're looking for the range of the g of x. Okay, so we have to do it step by step because we want to make sure that there is no we don't miss out any numbers that cannot be in that range. Get it? So we're going to do it one by one. So you see here, we have this, right? So the domain is going to be -3 and 3, correct? It's going to be within this range. So then it has to go through the f function first. So we know that f function is what? 9 minus x squared, right? So how is that graph look like? That graph, because it's a negative x squared, so it's going to be an n shape, correct? It's going to be an n shape graph because it's a quadratic, so it's n shape, and then positive 9 here, so it's going to be like this. By right, it's supposed to be like this. Okay, here is 9. But because the domain is only between -3 to 3, so we know that -3 is what? It cannot be, we cannot include the bottom part here because we know here is -3, here is 3. So the domain is only going to be within this range. Okay, you're not going to extend this, it doesn't exist because it's only between -3 and 3. So because if it's only within this range, we know the fx, the range is going to be what? The range is, sorry, why did I write this? So so the range is going to be between 0 all the way to 9, right? Because this is the fx, by the way, this is fx. I'm doing fx now. So it's only going to be between 0 to 9 because down here doesn't exist. There is no graph at the bottom, and there is no graph beyond the beyond the 9, correct? There is no more graph up here, no more graph. So it's only going to be from 0 to 9. So that means that is your range of fx, 0 to 9. Okay, so now we're going to go through the g function. So wait, let me write this. So now this one is going to be the domain. This 0 to 9 will become the domain of the g function, correct? So 0 to 9 is going to be the domain of the g function because now it has to go through the g function. So what is it going to become? So g function is this, right? Square root x. So you know that when the domain is 0, so square root 0, you get 0. And when the domain is 9, square root 9, you get 3, right? It's not going to be negative because, like I said, there is no negative graph. So it's only at the positive. So the answer is between 0 all the way to 3. So that would be your range. So the range of g of x will be between 0 to 3. Okay, so this is how you do it. Okay, this one seems a bit more complex, but basically we just want to make sure that we don't miss out lah. Okay, so yeah, now let us go to actual exercises. Okay, then you understand better. Okay, so here are some basic examples. So let's look at this. Question A, they want fg -4. So we get, since there is an input here, we can find the g -4 first. G -4 will be equal to 4 minus -4. So your answer is 8. Then you've already gotten 8, right? So now you have to find f. Okay, so fg -4 is the same as f8 because you already know that g -4 is 8. Okay, so you just substitute 8. So you get 2 times 8 plus 1. So 16 plus 1, 17. So square root 17. Okay, so this is your answer. Question B. GF12. So GF12 is going to be, okay, let's see, F12, right? We're going to find F12. Where is F? Okay. So 2 times 12 plus 1. So you get 24 plus 1, 25. So this your answer can be, they never give you the domain, so it can either be plus minus 5 lah. Okay, either one. Oh, wait a minute. Have I done? Oh, wait, sorry. What am I doing? We are finding for F, right? So this is not G. So, okay, we just assume that it's positive first lah. Okay, to make it easy, we assume it's positive. So then we can find GFX, GF12. Because we already found F, right? F12. So it's going to be G5. So it's going to be 4 minus 5. Answer is -1. Okay. Question C. Alright, now there is no input, right? There is no x value here. So we have to take the gx, substitute as input into the fx. So fx is 2 times x, right? But now the x here, you have to write the g function, then plus 1. So you get 8 minus 2x plus 1. So your answer is 9 minus 2x. Okay, right, the last one here, question D. You've got gfx. So now you have to substitute fx into the g function. So the g function is 4 minus x, but the x here you have to substitute with square root 2x plus 1. So this one, that's it, like you can't really do much. So it's 2x plus 1. That's your answer, right? Let's look at the next one. Alright, so this one is a bit more complex. So question A, they ask for f square. So f square is actually what? F, double f, right? So it becomes fx, substitute back into itself. Where is fx? Fx is this, x plus 4. So that means x plus 4 plus 4 again. Okay, so you get x plus 8. Next, g double g here, ggx. Yeah, so gx is 2x square, so that means you have to substitute back into itself. So you get 2, so the x here becomes 2x square, and then on top of that you have to square again. Okay, so you will get 4x power 4, you get 8x power 4. Okay, that's how you do that. Okay, question C, h square. So h square will be h double h. So double h. So h is where? Okay, h is this. Okay, so I'm going to substitute it back into itself. So you're going to become 2 times 2x, right? So the x will become hx again plus 1. So this one is a bit more complicated. But what we can do is we can multiply by 2x plus 1 on top and bottom. Why am I doing that? So that I can eliminate the 2x plus 1. So I get 2x plus 1 over 2 plus 2x plus 1. Okay, so your answer is 2x plus 1 over 2x plus 3. Okay, question D. So question D is, oh wow, this one is 3 functions here, 3 functions combined. Okay, so we do one by one. We find gfx first. So gfx is, you're going to substitute fx, where is fx? Okay, x plus 4 into the g. So g is 2, x is going to be x plus 4, then square. So we can expand this. You get x square plus 8x plus 16. So expand this again, you get 2x square plus 16x plus 32. Okay, so we have already found gfx. Now we have to substitute into the h. So it becomes hgfx. So what is h again? 1 over 2x, so the x will be the gfx function. And then don't forget to plus 1. Okay, so your final answer is going to be 1 over 4x squared plus 32x plus 64 plus 1 is 65. So this is your answer. Okay, so I've prepared this one past year question for you guys. This is the actual past year question so that you can try. But if you can't do, don't worry, because these are actual past year, so maybe you still haven't got the hang of it yet. So never mind, we'll go through this together. So the first one, they ask for FG8. FG8. So you can find G8 first. G8. So substitute 8 into the G function. Where is the G function? Okay, so you get 8 plus 1. Answer is square root 9 is 3. So of course you can write plus minus 3. But since they say the domain here, what? X is more than negative 1. So there is no negative. So it's only going to be positive 3. Okay. Question, okay, second. Oh wait, not done yet. Sorry, my bad. We want to find for FG, right? So FG8. So you already found G8 is equals to 3. So it's F3. So it's going to be 2 times 3 over 3 plus 1. So answer is 6 over 4, which is equivalent to 3 over 2. You can write like this, or you can write in mixed fraction. Okay. Next question. Okay, second one. Find an expression for f square x, which is f double f lah, giving your answer in the form of, so they want in this format, and they want, okay, so you, based on this you can find a, b, c lah. So let's do that together. So double f, so double f will be 2 times, I'm going to substitute back the fx, so it's 2x over x plus 1 over 2x over x plus 1 plus 1. Okay, I hope you understand what I'm doing, because the original equation is what? 2x over x plus 1. So this x and this x, I substitute with the fx again. Okay, so I hope you understand what I'm doing here. Now, let us expand this. So what we can do is, I can just multiply x plus 1 on the top and bottom, so that I can eliminate this. Okay, so what you will get is, so you will get 4x over, so at the bottom here you get 2x plus x plus 1. So your answer is 4x over 3x plus 1. Okay, so the second one done. Oh wait, they asked for ABC, right? So A, B, C. So from here we know that you just have to compare. They asked for AX, BX plus C. So from here we know A is equals to 4, B is equals to 3, and C is equals to 1. Okay. Question number 3. Find the expression for G inverse. So they ask you to find G inverse, and stating is domain and range. So G inverse, let us do G inverse. So Gx is square root x plus 1. So wait, let me write here, question 3. We know that Gx equals to x plus 1. Okay, so we change the Gx into y, and then we're going to swap places between the x and the y. So x becomes y, y becomes x, and then we're going to make y as the subject. So you get x square minus 1 equals to y. So the y here is the inverse function, so it's going to be G inverse, x square minus 1. Okay, so this is your answer. So domain and range, how do we do that? So in our previous video, inverse function, I taught you all right. I said that the domain of the forward function will be the range of the inverse. okay, will be the range of the inverse, and vice versa. The range of the gx, the forward function, will be the domain of the inverse function. Okay, so I told you all this. So from here we can actually find the domain. They gave you the domain of forward function is this, x equals to -1. So this domain here is x more than -1. So because of that, the range for the G inverse is also the same, but instead of writing x, you have to write y, because now it's range, right? So y more than -1. Okay, so we've already found the range. Now you want to find the domain. So domain of the inverse function is going to be the range of the forward function. So you just have to know the range of this forward function. So how to find the range? I would suggest you draw the graph, okay, because it's better for you to draw the graph so that you understand why that it is clearer, like you can get the answer better. Okay, so let's say this is the graph. Here is x, here is gx. Okay, we are drawing the forward function. So how do you draw this? Square root x plus 1. Okay, so for those who don't know, if you have a square root x, okay, how does this graph look like? The graph looks like this. Okay, it looks like this. It's a curve lah. But if let's say you have a plus 1 here, plus 1, when it's plus 1, you are going to move to the left. Okay, plus 1 you move to the left, minus 1 you move to the right. So in this case, plus 1, you're going to move to the left by 1 unit. So instead of starting from 0, you're going to start from -1. Okay, so this is your graph of gx. So if you notice, you see the domain is what? From -1 to infinity. That's why you see here, from x is going to be from -1 to infinity. That means it just have to be more than -1. And what's the range? The range is going to be from 0, because you're starting from 0, right? From 0 all the way to infinity, as high as possible. It doesn't stop. Okay, so because of that, we know the range is going to be from y is going to be more than equal to 0. Okay, it's going to be more than equal to 0, because it's going to start from the origin here, and then it goes all the way up. It doesn't stop. Okay, if you allow the graph to just go on, it will just go on forever. Okay, so it's going to be until infinity lah. So that means the range of the forward function is y more than equal to 0. So if that's the case, we know the domain is going to be, instead of y, we're going to write x. Clear? So that's what that's the answer lah. So domain of the inverse is x more than equal to 0, and y range is y more than -1. So let me write here. So the domain of G inverse is x more than equal to 0, and the range of G inverse is y, was it more than -1? I think so, yeah. Y more than -1, x more than equal to 0, yeah. So this will be your answers. Okay, these two. Done. Alright, last question, what they asked for. On axes like the ones shown, okay, sketch the graph. So they want you to sketch two graphs here. The first graph is y equals to gx, and another one is the inverse function, and then indicating the geometrical relationship between the graph. So I also taught you all this in the previous video, the inverse function. I told you that when you draw a graph, the forward function and the inverse function are actually reflected. Okay, it's actually reflected. So how is it reflected? It is reflected at the y equals to x line. So let's say this is the line. This is your this is y equals to x. Okay, so we know that just now we drew, right? We drew the g function gx, -1, and then it's going to be curved like this, right? That's what we drew just now. So you're just going to reflect this, because this is your gx. So we reflect this, upon the y equals to x line. So here is -1, and then it's going to do something like this. Oops, sorry. Wait, my bad. Something like this lah. Okay, so it looks like a reflection. Clear? So this will be your G inverse. So both lines are reflected at y equals to x. Okay, clear? So this is your answer. So that is all for this video. I hope you understand, and I hope you find it useful, and until next time, hope to see you on my next video. Take care. Bye bye.